Right. Welcome to this Open Security Summit session in May 2021. This session is, I'm going to present, but please, feel free to ask questions. Some of these topics are controversial a little bit, right? So feel free to ask questions, chip in with your audio questions, or put a video on if you want. And I want to talk about a kind of a concept that I felt that a lot of development teams don't do this. And I feel that it's one of those cases where I thought until I ran my own development teams that it was just because there was not enough space to do that. But, or there wasn't a mandate, or they wouldn't be asked to do it. But I kind of realized that it's really hard, right, to create an ecosystem where you can, have this environment where, like I say here, for bugs start with a passing test, right? And then we hit 99% code coverage as a side effect of that. And it's one of those things where it really is the foundational problem of most of our testing, our security, our lack of diagrams, for example, etc., which is that in most apps, there isn't a solid understanding of how things work, right? You can get it to work, you can do a lot of development, you can get it to the point where it behaves the way you expect it to behave. But, to have a really solid understanding of how everything works, you really need to have a really solid test framework, and more I kind of, believe that the test framework code sometimes is more important than the actual code of the application, because a great test framework will promote very effective code, very clean, very factored. In a way, the quality of the final code is a direct relationship with almost the quality and the scalability of the test framework. And that's the kind of stuff that I kind of want to cover here. So one of the key concepts here is that, a lot of the test-driven development, right? There's this idea that you start with a failed test, right? You write a failed test, and then you kind of describe kind of what you wanted, and then eventually you bake your code into doing that, right? I think the problem with this approach is it only works in some scenarios, and actually in practice, I've seen very few teams really doing a test-driven sort of work. And I actually think that test-driven development got a really bad sort of rap because there was a lot of bad implementations of it. It's kind of like agile, right? Where you have a lot of agile teams not really being agile, but then not really succeeding. I think there's a lot of teams who try to have high, for example, rate of code coverage. They try to do test-driven development, but do it the wrong way, and they end up creating massive, big elephants, right? So I kind of want to try to propose here a different approach, which how I think a lot of development should occur, right? So the way I look at this is that if you want to do test-driven development, you to be productive, you really need a kind of a real-time unit test execution, right? And ideally, right, when your hands lift, they should execute, or you should be able to have a kind of a very quick sort of command that you execute that it runs the test. So for example, to give an idea, if you use Wallaby and Crunch, they're amazing. Highly recommend you to use them because they give you this for Node and C#. But for, for example, Python, you can have on PyCharm or others, you can have like this command that you code. So you type that, for example, for my one is Command Enter, which is almost like, second nature to me, where it just triggers the test or triggers a particular test that you're running. And the key of this is to really also give you that sort of real-time code coverage. And, the focus should be on making the developers more productive and preventing them from switching context, right? And I think that's super critical. And one of the nice side effects that you see happening when you got test-driven development, i.e., when everything you develop is through a test. And one of the things that I kind of already pushed to some of my teams is that I kind of ban main. You should never have a main, especially to execute stuff, right? Because it's just cheating and it's not replicable. But you should really not have big sort of tests that execute large chunks of code, which is important in some cases, but you want to be able to be quite granular. And to every little code change you do, you should be able to modify a test that confirms that particular change, right? And a nice side effect of this is that when you develop like this, you get a huge amount of code coverage, right? Almost without trying, right? Which is very important. And by the way, you should, the sooner the project is, the more, like easy it is to achieve 100% code coverage, right? Because, if you can't get 100% code coverage in the beginning of your project, when you're going to get it, right? So it's important to do it from the beginning. And then this is kind of a very key concept, right? 90% code coverage, which of course there's lots of gaps, etc., which already why it shouldn't even be seen as initially a very solid metric, is not the destination. It's kind of base camp, right? So the way I look at this is that if you want to climb the Everest, you want to go to the summit, base camp, which is basically one of the first milestones, that's when you get 90% code coverage, right? You still have all these other major milestones. You still have all these extra capabilities that you now need to do, extra journey that you have to do in order to really achieve that, peak of deliverable and that, really amazing coverage. And which fundamentally, remember, is to give you confidence that the application is working the way it's supposed to work. More importantly, to allow you to refactor and keep improving the application at high speed. And that's really what we want. We want this mode where the more code you have, the faster you can go, right? And I actually find that a good example of a property of an application that is not, now in a good state, which is the more code you have, the slower you go, right? So this is a very powerful property where, the more, modules, the more capabilities, the more testing, the more, padding that you have on your code, technically the easier it should be to refactor, the easier it is to make changes, the easier it is to, keep improving the application 1% a day, which then of course with compounding, interest, gives you a massive amount of changes. So here's a case study, right? So let me walk you through when I create a vulnerability, and also a good example of how I would like these things to be shown in the code. So here's a code, and sorry about the change of format, because I haven't had the time to put everything back in the same format. So here's a feature request, right? So the feature request is, we want data editing on a UI, right? So the UI says, I need to edit some data, which basically means that the UI needs to send some file contents with a file name. So this is CoffeeScript, but I'll walk you through the code very quickly. You take a file name, you take a file contents. So if the file name or file contents, does not exist, you return null. If the type of file content is not a string, you return null. This file path allows you to find the file name already in the existing file system. And this is just basically, if that doesn't exist, we basically are going to combine the data path with the file name, and then we're going to write the file contents, right? So this is designed by the controller. Now, for the security participants on the call or developers, can you spot any vulnerability in this flow here, where you take the file name, and eventually the file name is going to be here, and the file contents is going to be written here to the file path that will contain the file name. Any vulnerability comes to mind? So you want to think about what happens if this, actually let me change color, right? If this is malicious and if that is malicious. Cool, so we got, yeah, Girandis, hope I said that correctly, is saying remote file inclusion, right? Which is correct. So one of them is, what happens if the file name actually contains dot dot backslash dot dot backslash and then the file name. You actually are going to write the file contents into the file name. And this is one of those cases where the interesting case here is that this is not, currently, exposed. So that this function here is being exposed by an endpoint, right? So basically there's an API REST endpoint that is going to call this guy. So So one of the things that I like to do from both a static analysis, but also from a security point of view, I really like the idea that you really want to tag this function here as a vulnerability, right? You really want to say this function is vulnerable to X, and you want to go there is vulnerable to Y. Also that. Now, is this going to be, a high risk vulnerability, right? We don't know yet, because it all depends on a lot of things, right? So, for example, it could be that, this particular path is running off a Docker or a volume that doesn't allow you to write outside of a particular folder. So although technically you might be able to say write in somewhere else, the account that runs this might not have the power to do that. So again, it would be like it's a vulnerability, because I would argue that it's a bug and a vulnerability actually, because he has behaviors that are not the expected behavior. But you could say the vulnerability might be low risk if other mitigators are in place, or it could be high risk if this allows you to take over, for example, a server, which could be possible because these vulnerabilities can allow those kind of things, right? So basically now, so here's what I then did, right? So I created a bug, right? So I actually created an issue, right? And I actually said that this function is vulnerable to path transversal. So like I said, the current implementation of the data set file data is vulnerable by design to a path transversal attack. So this would allow any caller to write the files outside the expected data folder. So in a way, I'm capturing as a bug. I'm almost capturing almost as a feature at the moment of this, where I'm saying this particular function has this type of vulnerability. And this is very important because it means that any callers to this function is going to have this vulnerability. Now, some callers might be able to protect the application against that. For example, if you validate for the file name for certain characters upstream, right? But it's very important that at the code level, we capture this vulnerability. So what you do here, right, is, and this is the key thing, right? So the first thing I write, and at this case, was actually a security test, right? And you can see, right, there's the issue type, right? The issue number, actually this case was 21, right? But you can see set file data path transversal. And what this is a test that is going to confirm that if basically I have a payload, sorry, so I'm just going to annotate. So this basically means that if I have, a payload, sorry, I need to go back. Here we go. So if I have a payload that, in this case is this one here. So you can see that my payload is going up. And what am I confirming? Am I confirming that when I call this with my payload, which is there, right? I'm actually going to confirm that the data path, when I combine my payload, is actually, the file contents is the new content. So I'm actually confirming that a file outside this case, the data root, was actually modified. And this is super important. So what you're basically seeing here is you're seeing, I wrote a test, and this is the thing that sometimes, depends how you phrase this, can be quite confusing. I wrote a test that passed when the vulnerability exists. I wrote a test that was green when the bug existed in the application. So it confirms to me that this particular vulnerability, is still there until this test actually fails. Any questions? And what you see, yeah, feel free to add the questions, right, as you come along. And the key of these is that I also then created a variation of that, because this is the thing that's interesting, right? When I was running then my tests, I realized that the string, for example, the file context doesn't check, right, for the size of the file. And the problem with most modern frameworks is that they allow literally gigabytes, right, of files to be sent, right, of a particular string of API if you don't limit it. So what I then found was that, and I wrote another test to confirm a kind of denial of service via the file name and the file contents. So what I was able to start to understand is that what happens if I send multiple files. So I create, a little util here that allows me to send multiple files with different file sizes, right? And understand the side effects. And I think here's a better one to view. So I started to understand, and this was actually using Wallaby, but in terms of the performance, I was starting to see what happens if I send 10 files with certain size. And then I was able to play around with bigger and bigger files, and how long it will take. And this is basically an interesting question where, in a way, this becomes a balance, then becomes of how much, it costs to send traffic through versus how much it costs to save the file on disk and how many internal calls you have. But you can see that I'm able to almost on a scientific way understand the side effects of what's happening. And this is my key point here, was I wrote a test to confirm the behavior of the bug that I was seeing. And that's super important. And I wrote a passing test to make sure that until the behavior changed, right, the test still succeeds. And in fact, you could see a little difference. If you look at the difference between this issue here, which is DOS via file contents, and the previous one, which via file name and file contents, you can see that the tests are a little bit different, because this one, the file name was still vulnerable, where this one, the file name is not vulnerable, which is actually a very important distinction. So in this case, when we're looking at the threat modeling of this, was like the file name, DOS, and injection was kind of a problem, but actually, this wasn't really a problem. So people can upload all sorts of file sizes. So that became less of an issue of how big that file was. But the other problem here was, and this is what's really cool when you start to run these tests, is you can also start to understand, hold on, and this was the other vulnerability, right? The other vulnerability you have with the original code base, which is here, which I found interesting that, even when I was reviewing this for the first time, I kind of gravitated, like we have here, for the fact that, you can write, files anywhere on disk. But it was only when I was writing the tests and I kind of did the threat modeling, understanding really the side effects, I was like, hold on, I can actually write files with different extensions. And then a couple of these became insanely dangerous. For example, .coffee, right? Or, because in this case, .coffee or .js, because this is a Node.js application, this actually give you remote code execution. And the only one that should be supported is JSON. So here's an example of we actually creating a file, and we actually, if you look at the workflow, this is a test that confirms the vulnerability. So in a way, this is a security test, and a bug test, because he allows you to say, for this bug, at the moment, I can create a file with all these different extensions. And I would argue that only this one should be allowed. None of this should be allowed. So this then, what we've done with it was actually we opened an issue to say, hey, actually, this allows you to basically edit coffee script files. This is now a remote code execution vulnerability. So related to the original one, you actually remote code execution. And here's actually was a POC. So again, this is a test that actually confirmed the execution. And this is the thing that I find that, security teams sometimes don't do very well, but I feel that it's super important, is that, if we want to have credibility to say this is a problem and this could happen and this is something that is an issue, we should be able to prove it, right? We should have the ability to write a proof that says, hey, this is an issue. And this is where the test framework really helps. The reason why a lot of this was possible is because the test framework on this particular application, which by the way, I think was the open source OWASP maturity model viewer, was a really, really good test framework. So I was able to very quickly, for example, write a test that in this case actually gets and executes the file. In this case, you could see, so I'm actually get file data that actually executes the code, because you could see there's my new file contents, which in this case is model exports, 42. So you can actually see that that function is actually executing this, which is basically not good at all, right? So again, but this is a test that confirms the vulnerability, and you can see here the risk high and the security issue, etc. How it was labeled. Again, feel free to ask questions. If not, I'll just keep going on this. And now the fix, right? So what was really interesting was that actually the irony was that the fix for this code actually made the code much more simpler, which was really interesting. So in an interesting way, it was a good example of the code for at least for the path transversal actually simplify the code, on it. And again, we wrote, basically a file that now, a test that now confirms that it's not possible to write files outside the data folder. So what you now have here is a test that basically the confirmation is that, for example, in this case, again, assert is null. When you send this now, we confirm that, we now don't get the sort of the new, the modification of the payload, right, now doesn't trigger the vulnerability. So you could see that, the sequence here was we wrote a bug. So in a way, the harder part here was write the first test. The test to replicate the issue, the test to effectively prove the problem was the one that was hard to write. It was easy to refactor these tests to then make sure that the test becomes almost a regression test to confirm that the vulnerability doesn't exist in this case. So, so let's look at what it looked like in the code, right? And I really, really like this, right? And I really like a lot of the code that I read actually look like this, right? So what you had was, before the vulnerability is created, this is what the code looked like. You got an API called list, your API called files, to return. This is CoffeeScript, right? Which is basically means that, just for reference, means that the tabs make a difference, right? And then here's the vulnerability. Cool, we add this method. This is now vulnerable to this. So the first thing we should do is we add some comments. See, look, to do add security risk, this method will allow this, etc. Add security risk, add security risk, add security risk, right? So, and it's interesting, you can see that in this case, actually, we hadn't picked up the remote code execution, but it is very important, right? The soon as the developer had the understanding that this was a problem, even if you don't create the issue straight away, even if there's a bunch of other stuff, at least start to capture right away what you want to happen. Then you create the issues on GitHub and you put a reference here. So now you can see that these issues, right, now exist in GitHub and are relevant to this particular function. So now, even if we don't decide not to do anything about it, there is an understanding in the code of the particular vulnerability or the bugs that affect that particular line in the code, and also vice versa, right? And then for what this means, it means that if you ever see in the code something like this to do something, you should really be, in a lot of cases, creating an issue, and sometimes you might need to have a separate, maybe just filter or org just for these sort of low levels. Or okay, this is security is a big one, but I would argue even small refactorings, you want to make sure that you capture that as a bug, because that's going to be a code change, right? So now you can see that we can evolve this, right? So evolve the comments where I've done the move. Okay, so there's check this, check that, do this, etc. And then what happens was, after we do the first fix, right, you update the issues. Now you could see now, so if you look at the evolution here, you can actually see that at this stage, the understanding was path transversal DOS allow creation of files with any extensions, where once we do, for example, the fix or some of the fixes, right, now you still have this one, but now you also have, okay, that's this one. So here, now once we add a particular fix, in this case, the file name, we now have the file data has remote code execution, which is this one here. We now added that issue there, refactored this. So you can see that in case here, we also have a bug that is not security. It's just that actually set file data should probably be called set file data JSON. In fact, that should be lowercase. But you can see that we can capture other issues that are related to this, but also we have the denial of service via file contents, right? So you can see that there's the evolution about the first fix. And then after the final fix, now the only vulnerability that we have is the denial of service via file contents. So you can see that we check both values, check if it's a string, check is actually JSON data. So we actually added another check here to make sure that the data is actually valid JSON data. Then we make sure that we resolve the file name, make sure the file exists, make sure it's actually JSON, right? And only after all of this, we actually write the file, right? And then we confirm the file will save okay. But you can see that now not only we got a very solid function, which still has one vulnerability, which is the file contents, right? Of the size of the file contents, which actually we call the JSON data here. We also have a set of tests that really validate this and make sure that in the future somebody doesn't come along and, for example, remove this line or changes this because, oh, maybe they want another extensions without realizing the whole side effects. Yeah, so there's a question here from John. I think the problem with large REST payloads has two dimensions. There's the buffer overflow and the denial of service. The former is a security issue, but I think you can argue that the latter is a case for not allowing external access to API endpoints, but instead of using a hardened reverse proxy ingress controller. Yeah, I think it allows you to then ask the question, who's responsible for controlling the size of the payloads that the application is receiving? Because the problem is, and actually it's a good point, I'm glad you mentioned Nginx there, because this is an interesting example that if you control, for example, the file size here, you still allow massive file sizes to arrive over here. So it's almost like, remember that this function, it's kind of like 6th or 7th in a sequence of events, right? You got the first layer, the load balancer, then you got the REST endpoint or the Nginx, then you got the REST endpoint, then you got the API call, then you got maybe a middle layer. There might even be a layer in the middle that then eventually arrives at the data store, which is here. Sometimes I'm a big fan of doing authorization checks as late as possible, but I'm a big fan of doing data validation and data sanitization as soon as possible. So in this case, you probably want to do it exactly on the Nginx ingress. As soon as you can get to, you start to validate and do some enforcements on some of the checks that are happening. So what we really want here is this TDD feedback loops, right? So here's another very cool example, right? So what you have here, right, is, and this is one of the environments, for example, I can have. Like if you think about it, I got a Pug, which is basically, it's like actually a really cool technology. It's a great way to write HTML. You got a controller, right, that is basically going to display that. You've got a page and you got the table controller, right? Now, you can see in this environment, every time I make a code change, I get the code executed, which is really, really cool, right? Now, one of the questions that is very important is what happens when you change the attack surface? So this is actually a question that the security team should also really care about, right? Because what you have here is basically this idea of when the attack surface changes, right? What clues do you have, for example, that the thread landscape just changed, right? So what I like about this particular test, so you can see that this is a test that is checking if the routes are still the ones that I expect in this case. So you can see controllers, redirects, angular routes, and here are all the routes on the application, and we're checking that they still are the same. If I come in and add a new route, one of the things that's really cool in this environment is immediately in real time, I see that this assert failed. And I get a really good clue here where it actually failed in the UI. So you can see that now, because I add a new route, my test failed. And what you now want, actually, I thought I had a screenshot for that. I guess I didn't. You want a case where as you add the new route here, that guy goes green. And I'll show you that example on one of the projects that we're working on, which is this folder to folder, Glasswall project, where we actually added a test, and you can see here the tests that we're doing. This is actually a fast API test, but we added this test here that lock the current rules mappings. So that means that I can now come in here and I can tell you straight away what is the attack surface of this application, what methods he has, and whether he has any kind of authorization or validation, etc. So it's really cool to be able to have this view where I can have the mapping, I can have the methods, etc., and the format, and you guys get to see again where some of the inputs and when some variables are actually exists on here, which is super powerful. So this is a good example of a method that we've added to the application we're working on that literally locks the attack surface. And every time you add a new endpoint to the application, you have to come in here and update this test. And this test is part of the CI pipeline, which then will break the build if that particular test doesn't pass, right? So it's really cool. So sorry, make sure the chat. Yep. Okay, so let's look at the TDD workflow for a bug, right? So normal workflow for bugs is literally like this, right? You find a bug, you create the issue, you prioritize, you fix, you create and deploy, and then you hope it's being fully fixed, right? And that's kind of usually a lot of the flow here, right? With the kind of TDD is a little bit different, right? You take the bug, ideally you kind of write this loop of you write a test that failed, you fix it, it passes, all done, etc. Right? The problem is very few do this in pure TDD, right? Very few actually write this like this. And again, this is very hard to do unless you invest in your test framework, which is why every time these bugs occur or these vulnerabilities occur, for me is a way to validate the quality of your test framework, right? Because in a way, to do this, you really need that test API infrastructure, because a lot of the times it's very hard to replicate the exact failure, or it's very easy if your framework already supports it, right? And here's the thing, right? One of the reasons why it's very hard is because when you need to improve your API and test infrastructure, if it's not in there, are you able to spend the extra 4, 8, 16, whatever, fixing a blind spot in your test APIs, right? So the end result usually is very, very shallow tests. And that's a problem, right? Because you really want to be able to write a full suite of tests that actually validates the bug that you have in mind, right? Because usually, the root cause is sometimes of the issue, sometimes either is not fully identified, or you just have a shallow, validation of that particular issue, or you fix it not maybe in the right place because you don't have the right tests, right? So for example, here's an example of how do you know what failed, right? So given these bugs, login plus open page plus enter data, submit data, there's a bug. Create object, populate with data, do action, bug occurs. Call service, inner call to service A, call to service B, bad data return from service B, if a bug happens, right? If you write a failed test, what happens when the problem occurs before we reach the bug happens? So what I'm saying here is that, the reason why I'm saying that, you want to write a passing test, right, for the bug is because you cannot write a failed test here, right? Because it's already failing, right? Because by definition, right, you got a failing proposition, but there's lots of things that can occur on the way to the bug, right? My point is that, you want to make sure that you write a test that can replicate this. In fact, one of my favorite workflows when I'm coding a bug is I actually write a test where I start from the moment I've identified the bug. So I actually end up writing one test here, then a test there, then there, then there, and sometimes even, in a methods until you hit the bug. And then what's really cool about this, it means that now, actually, in this case, sorry, I should have said this is a green test, right? Actually, what actually happens is, imagine that all these tests initially were green, right? Because I wrote a passing test to replicate the bug, right? And then actually what you want to see is when I fix the bug, you want all these tests to start failing, right? Especially depends where you fixed it, right? So if you actually fix the bug at the bottom, you want all these tests to fail, but sometimes you end up fixing the bug here, right? So actually means that if you fix, so this is the weird one, right? So if you actually had these tests that were passing, right, and then you fixed it over here, it means that these tests still pass with the bug, and these tests now fail because you fixed the bug. So this is all the stuff that you need to take into account, because it might mean that, hey, you know, I fixed it over here, but I still leave the vulnerability behind in these locations, which might not be a problem today until somebody comes along and wires up, right, the codes into one of those vulnerable endpoints, right? So this is my point here, that, you know, you want to make sure that you write a passing test because you want to distinguish between the current behavior or the current feature, which is when the vulnerability or the bug exists, right? Versus when you fixed it. And this is very hard to explain, but I've experienced this personally, where you write a whole bunch of tests to confirm the vulnerability, you fixed it, you know, in the way you believe is the best way to do it, and you expect everything to go red, for example, and only some of them go red, i.e. some of them, the vulnerability is still there, right? And then you go, oh, you know, what's happening? And then you realize that you made a mistake in how you fix your vulnerability. So it's super powerful to have that capability. So again, lots of, you know, bugs that you need these things, from headers in production to the bug message shown on production, SQL injection, wrong product, wrong link, performance issues, inconsistent error message queues, accepted there with bad data, user influenced by prior manipulations, overposting, user strings on models. So all this stuff, right? That all these bugs and all these security bugs, you really want to, in this way of writing, you know, tests to replicate the issue. And ideally, you should already have security tests that test for all of this, which is actually one of the things that I know that is being talked on Friday. Again, if you guys come on the session on Friday, because I know Mario is also talking about use cases and writing about it, right? So the thing about this is that some of these are bugs, some of them are features, right? You know, in a way they are, you know, even when they have security implications, they are represent the behavior of the application, right? So my definition of feature is that once the code hits the main develop branch, it's a behavior, its behavior is a feature, regardless if the code's in production. So you want to start treating it like that, and you want to write tests for it. So the bottom line is, until you write the passing test, you don't really know the root cause of the issue, right? Because it goes to the bottom line of it. And here's one of the things that also happens a lot with security, right? But also with that other bugs. You find the issue, somebody creates a proof of concept, you report the issue on PDF or bug tracking, the dev kind of fix it, push the fix to production. If you have no test, you know, most likely you're going to come in, do a variation, and then start again, right? And this is what I used to experience a lot. And I realized the problem was that I was not giving developers very good tests, which was my proof of concept. So that was kind of the way you address this, right? And much, you know, and of course, you know, a lot of this is not super efficient, right? So what you want is a flow where you write a test first, then you understand the issue, right? Because you're writing the tests. This allows you to improve the test APIs and frameworks, which, by the way, can actually be a bigger problem than the first test. So the way I look at it is that if you're not able to test a particular things because our current test API doesn't allow us to do it, then that's a bigger bug. That might actually have more priority than sometimes even the bug that you had in the first place, right? This is what I was talking about before. You write one test per affected layer, right? Where ideally sometimes you start with end to end, because that's the bug that was reported. Sometimes that's where you really sometimes saw the side effect of it, and you end up with very, very pure unit tests. 100% focus on the root cause of the issue. And for each affected method, you write methods for each colors, which you kind of, and this is the thing, like once you find these affected methods, you should actually have almost a reverse tree of the bugs that are, you know, allowed to understand every single place where that vulnerability or that bug is actually in place, right? And then the cool thing is, when you fix the original problem, you should break all these tests that you then change it. And I have to say that I found a much easier way to read pull requests when I'm actually reading the diff of the tests of the pull requests, because the diff of the test actually gives me basically an understanding of what changed. Now, for this to happen, you have to have very good tests in the first place. And then what happens is these tests who are passing bug tests or passing vulnerability tests become passing regression tests. So they now are tests that actually now confirm that the vulnerability is, or the bug is being fixed, but also in the future will pick up similar issues, which again is super powerful. And the QA team and manager, architects, and security teams should actually be reviewing the diffs between these commits. So I can look at a diff and tell you if I'm confident solution for a particular bug or particular vulnerability was actually correctly done. That's a big thing. And I feel that, again, it goes back to the idea that every time there's a bug or a problem, instead of straight away coding the fix or trying to hack away, you write tests that replicate the current behavior, including the behavior. Again, any questions, speak, or ask the question in here. So the final steps, here basically is tests should be the lingua franca, right? So tests should be able the way that multiple teams communicate, should be easy to write then explanation. So I found that when you get this right, it's actually easier to explain even behavior and features and all the stuff. Sometimes using tests or screenshot and videos, literally the execution of a test should actually almost read in English, right? To say whatever language you're coding on, right? The explanation to say this is what is actually happening. And it should be, if you refactor your code and your test code effectively, your test code should be very easy to understand from the point of view of what he's actually doing. And the team's collaboration should be done by a test, right? From dev to QA, QA to dev, from team A to team B, from dev to dev, etc. That's really how you collaborate on this. And ideally, managers should write tests, right? And they should be demanding, because they should have development experience, very powerful, easy to use APIs. Because by definition, a lot of managers, dev managers, they understand the bigger picture, they understand what you're trying to do, so they should be able to codify their requirements again on tests. For example, today might pass on a bug, but then eventually will be changed to pass on the actual behavior that is actually desired. And which actually takes to the next level where really managers needs to code, right? So little rant here to say it's crazy that we tend to promote the best developers to manage position, and then we actually make them everything except coding, right? So the senior devs should be usually are the best programmers in the building, so they should basically live coding, but of course they don't have all the time to code. But what they can do is they can read and write tests, which actually means that the teams communicate using tests, right? It is a very effective way of doing it. And by the way, I've also experienced this. Sometimes printing a test on paper is a very effective way to do code reviews. But again, it all goes to the idea that tests are the lingua franca of the dev teams. And here's a very cool concept, right? When you create a test, the fix stage, the focus and time allocated is on fixing the bug, not on fixing the test framework. When you're creating a test on the issue creation stage, the focus and time allocated is how to test it and what is the root cause. So what I'm basically saying here is that we should write the tests that pass, that represent the bug, when we are opening up the issue as part of a development, maybe set of activities that are not focusing on the fix, are not focusing on how to actually address this particular bug. They just simply focus on, can we correctly replicate the scenario that we're trying to test, or the scenario that we're trying to do, or the thing that we, it's almost like defining the success criteria, right? When we, when we're opening up the issue. So then, it's much more easy to say, oh, hold on, we need to do an extra piece of work because we don't have the technology, we don't have the workflows, we don't have the language, we don't have the test suite to be able to correctly replicate the bug that we have, and eventually correctly replicate the behavior that currently is not what we want, and then the behavior that we want it to exist. And this is where, again, you can expand this to say, okay, I need to develop some extra things because once I get the functionality, I'm going to need it. The point is that if you wait for the fix stage, usually there's not a lot of time to improve the test framework, which is why you end up with this model that doesn't really work. So, any final questions on these ideas. All right, no questions? If not, I think that was it, right? That was my session, right? That was the sort of the topics I want to cover here. All right, cool. So we'll end the recording and we'll continue next time.